everyone, my name is Grace Ellers, and today we are going to be talking about nuclear waste, in particular the process of repurposing toxic waste into new fuel. A lot of people have misconceptions about nuclear waste, specifically that it's this green glowing goo that could spill out at any moment and cause health problems. And that is kind of true, actually, but not the green glowing goo part. But yeah, if left unsupervised and not stored properly, the nuclear waste can be harmful, but we have really reliable ways to store nuclear waste. In fact, the storage of nuclear waste is much less likely to cause any environmental or health problems than the waste from fossil fuel burning plants. Our planet really needs a sustainable way to produce green energy. This is why recycling our current nuclear waste deserves a closer look. There are 3 different levels of nuclear waste. Low-level waste is only harmful for a short amount of time, intermediate for longer, and high-level for a very long time, like a really long time. This high-level waste is what people are worried about. Even though high-level waste only makes up about 1% of the nuclear waste we have right now, it's still something that we should be worried about because of how radioactive it is. Deep theological disposal is what we are currently using to dispose of this type of waste, but what if I told you that there was a different way that allowed us to recycle this waste and give us new green energy at the same time? I bet you'd be really proud of me in science. Well, good news. Science can do this. The high-level waste, or used fuel rods, is the type of waste that we can recycle. Used fuel rods are made up of 96% uranium, 1% plutonium, and 3% good old-fashioned fission products. The first problem that we run into is that we can't reuse the 3% fission products, so we have to find a way to separate the useful stuff from the non-useful stuff. We can extract the good parts by putting it through a process called pyrochemical processing. The first step in pyrochemical processing is heating up a huge vat of lithium chloride and potassium chloride salt to about 550 degrees Celsius. Once the mixture is a liquid, it then acts as a solvent. We can then break down all the fuel rods into small pieces and put them into a cage, and then put that cage into the vat of salt. Then we will run an electrical current through the vat to create an electrochemical cell. The cage will act as an anode, and all the good stuff will be drawn to the cathode. We can then reuse all the crystallized uranium and transuranic elements that formed on the cathode to create new fuel rods that can be used in fast breeder reactors. Now that we know how to recycle nuclear waste, let's talk a bit about the reactors that can run on this waste fuel. Because most of the uranium that we just repurposed was the fertile uranium-238. We can't use the same way that we can use uranium-235 based fuels. So, not like the light water reactors that are used in most of America today. But never fear, for there is a type of reactor that can use uranium-238 as the fuel. This type of reactor is called a breeder reactor. Breeder reactors work by using spare neutrons to force uranium-238 to undergo beta decay to produce plutonium-239, which is a highly fissile element. Once we have plutonium-239, the spare neutrons will bombard the nuclei, forcing it to split, thus creating heat, which creates steam, which spins a turbine, which gives us energy. So here we are. We explored a process that not only allows us to do something useful and recycle our waste, but also it produces much more needed green energy in the process. We're saving 2 birds with 1 nuclei. So hopefully we are now clear on nuclear. Sorry I had to. Thanks.